Hello and welcome. In this video, we demonstrate loops, our locally optimized Polygon simplification algorithm. In our application, we have a simple static train of Switzerland on which we draw vector data using loops. In this example, the dataset represents the forest regions. It contains more than 200,000 2D polygons which have in total more than 13 million line segments in their outlines. The data is already pre-processed and stored in GPU buffers. At runtime, for each pixel, the algorithm accesses these polygons and draws a simplified version of them based on the error tolerance. We can set the error tolerance manually. If we increase it, the polygons are shown with low details. If we decrease the error tolerance, the polygons are shown with finer details. To better show how the error tolerance works, we use a lens tool. The error tolerance inside the lens is set to 0 and outside it's set to a high value. In this case, nothing outside of the lens is needed to be refined. However, a minimum amount of detail is shown outside of the lens to maintain the continuity of the polygons. The purpose of the lens is to show how fast the polygons can transform from no details to full details, and also no matter how radically the error tolerance changes, the polygons are always valid, with no discontinuities or intersections, even the ones on the border of the lens. We can define the error tolerance as a function of distance from the camera. Now that the function returns an error equal to 1 pixel projected back to the train, the LOD changes are not recognizable anymore. Benefiting also from deferred vector rendering, we can consistently display the polygons with pixel precision. In this example, the dataset represents water bodies of Switzerland rendered over a static textured terrain. This dataset contains more than 20,000 polygons with almost 2 million line segments in their outlines. No matter how fine the details are and how many holes exist inside the polygons, loops can display them precisely. With the help of the lens tool, we show how the holes inside the polygons are simplified without conflicting with the main polygon and disappear as soon as they are not needed. In this experiment, we placed a secondary camera near the terrain to observe the changes of the polygons, while the main camera moves from far away towards the place that the secondary camera observes. Also, the heat map shows the number of active triangles being drawn by loops at each pixel. The number of triangles increases as the main camera gets closer and more details are shown. We can use different LOD functions for calculating the error tolerance based on the distance from the camera. In the left experiment, the function projects 1 pixel on the train and returns it as the error tolerance. In the right example, the function projects 8 pixels. In both examples, the polygons are refined as they get closer to the camera and are simplified as they get farther. But in the left example, where the error tolerance is 1 pixel, the changes are not visible, while the changes in the right example with 8 pixel tolerance are obvious. In the end, we showed that loops can also draw open polylines in addition to polygons using the same data structure and algorithm. In this example, the dataset represents the whole street network of Switzerland. The lines have 5 different categories and are stylized according to their category. We can also change the error function manually. When we increase the tolerance, the lines are simplified, and when we decrease it, the lines are refined. The lens tool can show us how the details of the lines change as the lens hovers over them. Thank you very much for your time.